Hey guys, welcome back to the shop. Frank here. Gonna make some more progress on the Cub Cadet forklift build. Got it mostly stripped down. Gonna take a couple more items off and then mark the frame, get ready to cut it. It's a sizable piece of steel. That's for the lift. Holds one end of the lift cylinder. Won't need that anymore. Clean up some of these tools. Spent roll pins. Whoops. All right, so my plan is to cut down here, over here, down here, then over here, and then down here. So the cut line will come. All right, so that'll give me a zigzag cut, and we'll fit a piece of metal in that. That gets rid of this hole. When I lengthen this frame, however long we go, I'm going to have to take this step off and weld it back on, reattach it to the frame, because it'll still need to support the foot pad. You being a good boy? Huh? Come in to visit me again? Huh? Yeah, you're a good boy. You're a good boy. All right. You're such a good boy. Okay. That's my butchie. Of course comes my Brutus. And there of course comes my Brutus. You heard me talking to Butchie. You heard me talking to Butchie. Good boy. Good boy. Alright. Butchie comes back for some more. Alright, going outside now because I'm going to make some noise. Alright, so I will ultimately cut a zigzag for the extension. At least I think I will. But right now I'm just going to do a vertical cut until I decide the length of the insert. Just be simpler. Alright, so I got the motorcycle lift under the frame here. Hold it together. I'm going to clamp a piece of angle iron here. Alright, I'm not going to spend a lot of time trying to clamp this back in position. I was using these two pieces of angle iron to hold the frame in alignment after it's been cut. But I need to put longer pieces in there so we can stretch the frame out. So it's just held temporarily here, kind of awkward. So we'll start with like 12 inches and then see how that works. Got the frame clamped together here temporarily with about a 12-inch spacing. Lengthen the frame about 12 inches. I'm going to check this out. And here come the boys. It's Brutus and Butchie. Right on schedule. Every 20 minutes. All right, you guys. All right, go on. Good boys. All right. Good boys. All right, we'll see about putting a seat on here, and it looks like this might be, you know, reasonable extension. All right, I think we've arrived at a reasonable compromise here. Let's just check this distance here. Got 12 3/4. 12 3/4. That's 1 1/4 wide. Same at the bottom. And it's 7 inches. All right, I'm just looking at the overall scale of it and trying to make it no longer than it needs to be, because that increases the turning radius, and it's not going to be great as it is, but it'll be okay since it's the rear wheels turning. That'll help, but long enough for you to have adequate leg room. I think this is a reasonable compromise. A little bit less leg room than ideal, but better turning radius in the end. Okay, so we measured 12 3/4, lengthened by 12 3/4 of an inch, 12 3/4 inches, and next thing we'll do is go ahead and model a splice piece of metal to put in there in Fusion 360 and look at cutting it out on the plasma table. All right, I'm going to try to do this Fusion 360 demonstration. I'm actually filming the screen on my laptop because the screen capture software that comes with Windows 10, which is like a gaming thing, Windows button plus G brings up a capability to do screen captures, but when I did it, it didn't show any of the dialogues. It only showed the main screen, and it showed it shrunk. So hopefully this will work okay. This is Fusion 360. This is the main workspace. There are a couple of other workspaces. The one we start with is design, render, animation. I don't ever use those because I'm doing strictly two-dimensional work for the cutting out in the plasma table, and then manufacturing. I do use manufacture, and that's what generates the G code or the instructions for the plasma table. So we start out in design. We're just going to create a simple sketch. We hit select sketch. It brings up a XYZ coordinate system. I'm going to simplify that. Upper right hand corner here, I'm going to select the front. That gives me X and Y coordinates. I'm going to use my mouse to move the origin down a little bit. We click on that surface and that tells us that that's where we're going to do the work. You can see there's coordinates here, 5, 10, 5, 10, 15. And this is set to inches because it's been set in the program defaults. I go up here to the left-hand corner, to menu, pick 2-point rectangle. I'm going to draw a rectangle which is 12 3/4. You can see down here it's highlighted. It says 11 inches. You can just type in 12.75 and it will make that line, the rectangle, that length. Tab takes you up to the other dimension. We make that 7 inches and hit enter, and then it creates a rectangle of those dimensions. We made some notches in the frame, so I'm going to make another rectangle to fill that notch, and it is 2 inches long, and it's hit the tab key and takes us to the other dimension, and that's 2.5. Hit enter, and we can go up to the other corner, do it again, and these are the tabs we drew on the frame. Again, 2 inches wide, and I want it to be 1 inch. Hit tab, make it 1 inch, hit enter, so it creates another tab. These are individual components of the drawing, but we'll combine them in a minute. So let's zoom out a little bit. I'm going to do one more rectangle at the top here, and this is for the flange, and it's 14. You see it says 14.75 there, and we hit tab, we go to the other dimension. It says 1 inch. I want 1 1/4, 1.25. Hit enter, so that creates that flange, which will bend over. I'm going to try to bend it anyway. I don't have a brake, but we'll figure out some way to bend that over. And then down at the bottom I need the similar flange. Start in this corner, go all the way over to this side. It's not snapping to that dimension, so I'm going to tell it to be 14.75. Tab to the other dimension, make that 1.25. Hit enter, and it creates that rectangle. So now we have all these little rectangles. Press the control button, select with the mouse each of these rectangles, and so by selecting them all, I can create a single body from all of these components. If I right click, I get a little menu here. I'm going to hit press pull, and alright, so I got a dialog over here. It didn't keep all of my selections here, but if I reselect them all, I have this dialog. It says 5 profiles, 5 selected. The distance I'm going to extrude it, when press pull is really extrude, is 0.125, 1/8 of an inch. No angle. It's going to create a new body. I'm going to click on OK. So that combines all of those components into a single body. I can go up here to the right, top right corner, rotate this little cube, and you can see and I can zoom in. There's some thickness, and we have a body. So go back to the front view of it, zoom back out. So this is the piece of steel that we want to cut out. Over on the far left, there is a directory tree which allows you to look at your bodies and your sketches. You can turn the bodies off and turn the sketch back on, so you can control what you're looking at, what pieces of your overall design. And that's got sketches and bodies. Turn the sketch off and you just see the body. Of course, in a complex project, this would be, you know, a lot of stuff. So I want to save this project. I'm going to call it Splice 2. Hit save. And I'm calling it Splice 2 because Splice 1 was what I called the original file when I did the screen capture, and it did not work very well. So go to over here to the upper left, pick design, go to manufacture, and I'm going to change the dimensions from millimeters to inches. And there's 3 steps we need to do. First, we need to create a setup. So new setup. We select the origin. Go over here to this dialog. It's a generic machine for cutting. Go to the stock tab. No additional stock. There is a choice to add additional stock. And in the post process, we're going to call it, the file that we create, G-code file, we're going to call it Splice 2. Okay. So that's setup 1. And again, you'll have setups here and profiles and all the different components to your project. So here we have this body that we've selected. Can go into the profile dialog here. Since this is 8, I'm going to select the tool, go to my local library, select Crossfire Pro, which there is a set of instructions that are pre-saved for this particular tool. We're going to, cutting mode is we're going to cut through, default. All right, cutting feed rate. This is 1/8 inch, so that's cut at 65 inches per minute. Okay, 65, 65. Okay, whoops. Didn't mean to do that. That was the first tab. There's 5 tabs across here. Select the contour that's going to be cut. All right, all loops start on the outside. Retract height, clearance height, those sort of things. I don't normally change those. This is resolution, compensation, cut to the left, overlap, 0, stock to leave, smoothing, feed. I mean, there's other things you can do. Don't normally need to change any of that. Lead in sweep angle, lead in distance, those are kind of default numbers. I don't normally have to change those. Sometimes I'll have to reduce this lead in distance if I'm cutting a small hole. The 0.2, which is what this basically is, 0.2 inches, 2/10 of an inch. If you're cutting a 1/4 inch hole, that's too big. So sometimes have to reduce that for cutting small holes. But for this, it's just a plate. We're doing fine. Say OK on that. So there, it creates the cut path. We can pick the simulator here, simulate the cut process. There we go. You can change the speed on that, slow it down a little bit. All right, so that's the cut process. And we can exit the simulator, go back here to the menu, which is post-process. We're going to do splice 2. We need to use the fire control plasma cutter post file, and that specifies the cut height 63 thousandths, spring back is 20 thousandths. The torch height controller comes down and touches the top of the sheet and then raises up, and this assumes that there's a little bit of spring back on the sheet metal to allow it to adjust the cut height. Pierce delay 0.8. That may be a little bit much for this, but it'll work fine. Pierce height 150 mils, retract height 1 inch. The file name is splice 2, so we'll click post, and we get a message down here, NC code successfully posted. So that's the file for fire control. All right, we can go over to fire control, launch that. Already open. Not sure where it is, if it's already open. There it is. There's a process running. Let me end that task. Not sure why that was running. It was running from before. Alright, here's fire control. I can bring into the fire control splice 2. I got my puppy here. Butchie's come in to say hi. Alright. So there's a little bit of glare on the screen there. Hopefully you can still see that. Yeah, I don't know much I can do about that. Apologize for the crudeness of this setup, but for some reason I can't get the screen capture software to work. I may have to buy the module for my video editing software. All right, set program origin. We can pick the origin in the bottom left-hand corner. We zero all axes. So the intersection of these two white lines is where the torch is. This green line is its first free travel over to the entry point up here in the right-hand corner. Then it will cut around. And we'll come back when we go actually get the plasma table filled and set up and the air system charged, and we will run this cut program on the plasma table. We'll actually do it twice because we need to cut out 2 pieces. So we'll come back at that point. My apologies for having to do this with the camera on the screen. I know it's not the easiest thing to see, but until I can figure out a way to do proper screen capture that picks up all the dialogues, I couldn't figure out how to do it, and I have to find a an inexpensive software package that will do that. I'll try to do that next time. Okay, we'll come back with the plasma table. I'm pretty much set up here with the plasma table. For those of you who've been around and watched previous projects, especially the dozer build, you would have seen me use my plasma table quite a bit. There's a lot of footage on that project. Cut a lot of steel. But this is for those of you that are new, this is a Langmuir Systems Crossfire Pro plasma table, and it's powered by a 45 amp razor weld CNC plasma cutter. It's got what's called a machine torch as opposed to a hand torch. Just mounts easier. I feel like it mounts easier. And the table's full of water with a 10-to-1 ratio of preservative and anti-rusting ingredient, and I think it's called I don't know what it's called, Plasma 1100 or something like that. Anyway, you add, table holds about 15 gallons, so you add a little over a gallon, and maybe it's 20-to-1. Anyway, I forget. It's been a while since I mixed it up. So you add a gallon of the concentrate to the water, and it basically prevents rusting of the table. The pan is stainless, but the slats, sacrificial slats, are carbon steel, and so it prevents rusting. If you've seen somebody's plasma table they've used for a while that doesn't use a preservative like that in the water, it looks like a rusty mess. I've had almost zero rusting using this. So it drains when I'm done. There are 2 drains in the table, and it drains into this large sprayer tank down here, 20-gallon tank or 15-gallon tank, and it's got a pump on it, and I use a garden tractor battery, and I can refill the table through the hose here and discharge into the table. So I can pull the drain plugs, drain it to the tank when I'm not using it, and then pump it back up and fill the table. All right, so that's the plasma table. There's a control unit mounted on the side back here, and it's controlled by my laptop. It's IBM Ultrabook. I think it's a 460. So it's a few years old laptop, but it does run Windows 10 fine, and it runs this plasma table fine. It has adequate graphics in it. And for those of you that haven't seen, this is my little jib crane. It's a 500-pound capacity crane, and right now I've got a plate dog on it, and I use it to take sheets of steel out of this rack where I store my sheet steel. In this rack, they're all 4x4 foot pieces, and I'll roll this rack. It's on wheels. Roll this around, move the jib crane around, pull a sheet out of the rack, lay it flat on the floor, and then I get this magnet lifter here, put it on the crane, pick up the sheet of steel off the floor horizontally, swing it around, and set it on the table. So that's my material handling mechanism, and it works fine. I've used it for up to 3/8 inch steel. 4x4 sheet of 3/8 inch steel weighs like 375 pounds, but it works fine, and I'm just have to be careful. But anyway, so this little jib crane is a lifesaver. I could not handle the larger pieces of steel without that. What's on the table now is a piece of 1/8 inch leftover scrap from previous job. First thing I do is measure the distance between the edge of the steel and the table, both ends, to make sure it's square to the table, and that usually gets me square enough. And I'm going to move the torch over to a point here in the corner. We're going to set this as our work 0 and cut out the first of the 2 splice plates. Here in fire control, these arrows control the motion of the torch. Alright, so I've set this I've gone ahead and positioned the torch where I want to be my 0 point. I can go into the software here and tell it to 0 all axes. That puts the origin here in the bottom left hand corner. So the overall dimensions of this is 16.8 inches long, 9.63 inches tall. Now let's look at the sheet of steel here, make sure I have so if I'm going to cut 2 of these, I need 32 inches, or actually 34 inches. I've got 41 inches from there and 20 inches this way, 20 inches front to back. So it'd be better for me to turn the plate, the workpiece, 90 degrees and run it back and forth lengthwise across instead of this way. It would give me the scrap of metal left over would be larger, would be more squarish. So I can go into the software here, scale and rotate, turn that on. I'm going to rotate 90 degrees, create the new G code, and you'll see the layout changes. We'll go back here and set the program origin in the bottom left hand corner. Our torch is already there. We've zeroed all axes. Alright, let me just look at the G code real quick and make sure I've got alright, feed rate is 65, which is correct. Pierce delay 0.8, cut height 0.63. So just looking at the text here, this is the G code file, and you can scroll through it and edit it if you need to, but with a text editor. But it looks like it's right. Feed rate, pierce height, everything is good. Okay. So one other thing you need for a plasma table, if you're thinking about getting a plasma table, is a good air system. And I have a couple videos on my channel talking about my air system. I have in this closet, this is a sound barrier really. I have a 5 horsepower Ingersoll Rand air compressor, and the air comes off of the compressor through the hydraulic line up to a radiator mounted on the wall with a fan. So the air goes through the radiator, through a moisture separator. As it cools off, it's going to give up moisture, and then it goes back into the tank. So that removes a lot of the moisture out of the air before it even gets into the tank. And then the air comes out of the tank into this manifold. I got another moisture separator, oiler, which I don't use, desiccant, which I don't use, and then into this little triple manifold here. Goes to a couple different places in the shop. One of them goes to this refrigerated air dryer. So air comes in, goes to the refrigerated air dryer, and then there's another moisture separator on the output of the air dryer, and then that runs to That's basically, that plywood panel is a sound shield. Then that air runs to a large desiccant canister here. So this is a 10 quart, no, it's not 10 quart, can't be 10 quart. Well, whatever it is, 10 pound desiccant dryer, and then out of that into the plasma torch. So there's a considerable effort to get very dry air. If you have wet air going to your plasma torch, it destroys the nozzle and the electrode. The consumables don't last very long, and so you want clean, dry, very dry air. Okay, let's cut out a part. So it's cut out the two plates. So there we are. And there is, and you can see the quality of that cut. I mean, it's beautiful. There's virtually no dross on the back side. I mean, that does an excellent job. So those are the two splice plates for the tractor. We'll come back next week with those splice plates. We'll start fitting them up to the tractor and welding them in place, and getting the frame re-stabilized so we can continue to work on it. And we'll be using this plasma table quite a bit. We've got to cut panels to support the hood, cover the back of the dash, components for the lift itself, backrest, that sort of thing. So you'll see this being used quite a bit. I have no affiliation with Langmuir, but I have to say, this has become my favorite tool in the shop. It works. It was easy to set up. Not prohibitively expensive. I mean, you got to invest in an air system. If you don't already have an air system, you got to allow for that. And then the plasma table, and then I spent some money on this little jib crane, but I couldn't cut anything thicker than 1/8 of an inch probably without the jib crane, because the 4x4 piece would just be too heavy. I mean, you can lay it on the floor and cut it with a metal cutting saw into smaller pieces, and I have done that when I first got started, not knowing what the crane would handle and that sort of thing, as I started using the plasma table. So you could do that, cut smaller pieces. But even a 2x4 foot piece of 3/8 inches I mean, it's too heavy for one person to handle. I mean, you need someone else to help you pick it up. You're going to hurt yourself. So with this little jib crane, which I bought from Northern Tool, by the way, and again, no affiliation, no, I pay my own money for this stuff. You know, it's a good little tool. I've been happy with it. So, all right, that's it for this week. Leave a comment. Got any questions? Be happy to try to answer them. I do read all the comments. Appreciate you watching. We'll see you guys next time.